So now we're going to go through the whole process that the Terra 25 project went through before its bugs and risks were fixed. After the first few accidents, the head of the Advanced X-ray section in the CRPB, the Canadian Radiation Protection Bureau, made some recommendations to the Terra 25 project. The first one was to redesign the microswitch which controlled the selection between electron and proton mode. The second one was to terminate the treatment whenever dose rate malfunction occurred, in order to prevent obvious overdoses. And the third one was some recommendations concerning the change of command format, so that, for instance, a treatment cannot be proceeded after a bug by simply pressing a P key. However, these recommendations were purely centered on bugs and did not concentrate on changing the software design in order to prevent future and different bugs. So another action happened in 1986 which motivated the CRPB to take some more serious actions, not only concerning the Terra 25 project but all the projects in the medical device area. So from there on, all new medical devices had to be approved according to the risks they involved. They had to go through some serious testing, and some rules would be applied to it. Some corrective action plan rules, some cap rules would be applied to them. So the higher the risk the project had, the more rules it would have. And that was the case for the Terra 25 project, which had more than 20 rules. Of course, I'm not going to go through all of them here, because they are not all important to us. But the most important ones are, and they are, to make changes to hardware and software designs on the Terra 25 project in order to comply with basic hardware and software design recommendations for large-scale projects, and also to make some improvements to code documentation, which was reported to be pretty bad on the Terra 25 project, and to the manuals as well. And only after these changes would the Terra 25 work securely again. So now we're going to make some group suggestions to the project. The first one is to maintain good documentation since the start of the project. We've all been through some really bad documented Java and C++ codes, and we know how hard it is to understand it. But now imagine a microcontroller specific assembly code program. It is a lot harder to understand. And it is also important to maintain this documentation since the start of the project, instead of what the Terra 25 did, which was to program the whole project and then go back and figure out what the specific modules would do, and then document them. The second one is not to rely too much on software safety. Although we know that software is not prone to deteriorating over time, as hardware is, software is always more error prone than hardware, and also some redundancy on software on security is always good. And the third one is to perform a bug-centered development of the project. Is not to do it, which is what the Terra 25 project did, which is to develop the whole project and only then test it as a huge black box, looking for expected bugs and then fixing them. What should actually be done is a design-centered approach, which involves programming small modules, unit testing them, and then assembling them together into bigger parts which would be gradually tested. And the last recommendation is to log machine operations. in order to facilitate possible investigations. Of course, it's not good to assume that such a high risk project is prone to errors, but it always is. It always is. It is programmed by humans, it is developed by humans, so it is error prone. And actually, if the Terra 25 had logged its operations, it would have been some actions could have some accidents could have been prevented, since most of the accidents were resulted from the same set of machine operations. And even after some investigations, this set could not be discovered, and the Theory 25 just kept being used, which resulted in more accidents.